Sir, you're live now.
Okay, thank you. So, good afternoon, the NPTEL learners of the course Cathodic Production Engineering. Welcome you all for the live interaction. I do hope that you have had a very useful lectures so far, and you could be able to understand the fundamentals and solve some of the problems related to cathodic protection. So today, now we are meeting to have a live interaction so that whatever questions that you have, that I can able to address them. So please, one after another, send out your questions and I will try to answer them as we go along. So please do send your questions through the messages. Thank you.
So we have a question from the Excel. A person has already signed up.
Okay.
So he has two questions. Number one is, as suggested by you for measuring line current, the direction of current flow method, even at locations with positive shift, the line current direction is not getting reversed. So if there are two anode beds for two different pipelines placed at adjacent locations, interferences observed, what is the solution in that case?
Yeah, first of all, if there are interferences, I think I suppose you mean the interferences from the anodes or the interferences from the external sources like interference currents. The question, of course, that comes here is when you have two anodes, it is possible that the current will interfere, right? The field will be overlapping, and the current that is sent through the pipeline may not be the same for both the anodes, actually, right? So that could happen. That depends upon the location of the anodes with respect to place where you are measuring the current. So, however, when we are talking about the line current measurements, one thing that we need to keep in mind that we may need to put off one of the anodes. I mean, allow just only one anode and try to see how much of current is flowing in the system. On the contrary, if you are looking at the stray current corrosion, for example, okay, then it's an overwhelming current. The current, there's a net positive and net negative current that are flowing, right? It depends upon whether the current enters the pipeline or leaves the pipeline. I mean, the stray current would enter the pipeline. In that case, there will be certainly net current, which is cathodic in nature, right? The place where it leaves is going to be anodic in nature. So the sign will certainly be there. Okay. But I'm still not able to get the question so very, very clearly. And if you really have, further, points to clarify, I think we can discuss them offline so that, there's a clarity in what you are asking so that I'm able to answer you properly, actually, right? So I would suggest that let us discuss offline that particular one and, try to understand the question problem more clearly, and then you get the right answers. Thank you very much for the question. Can you move on to the next question?
So, Sridhar had sent some questions that is related to the answers, questions in the assignments. So, since it's a three-part big question, we will answer to him by email.
Okay.
So, Sridhar, I have seen your questions sent in the link, and also I have seen the chat box. I'll reply to you with the answers explaining to you. And for the previous question that he had asked, the learner has further asked, two anode beds for two pipelines are placed adjacent. again, he has repeated the interference is observed. How to solve this? Both are deep well anode.
Okay. Yeah, I mean, that of course is easy. It's easier said than done, actually. And I don't think that it would be easy for someone to just say you do this or you do that. Okay. I mean, if you have deep well ground bed anodes which are interfering, okay, then of course then you need to go more deeper into it, and where there are interface problem, maybe you can even have a common ground bed for both the pipelines. All this are possible. Sometimes we may have to do a modeling in order to find out what is the amount of current that is entering and all. Yeah, it's a very deeply involved problem. Okay, now I understand your questions a bit more clearly. Solving the stray current corrosion issues are much deeper problems. Okay, it involves many aspects. That includes, even one could even like to even model what kind of current that could enter from each of these systems, actually. And also, it depends upon the distances between these anodes and all, actually. Okay, so that of course is much more complex problem. Yeah. Thank you.
For now, we have answered the questions that has been put up. So,
Okay.
yeah.
Okay. If there are any questions which are live, I think we can still address them. Okay. I suppose there are no other questions. Then we can wait for another minute, I think. Then there are no questions. We can close the interaction.
Sridhar, thanks for the question. I'll answer it to you with the solutions. Taking in consideration with the solutions, I'll answer it to you on email.
Okay. Thank you then, Kirtika. Then we can close the meeting today. And if still anyone...
One more question, sir.
Great. Please go ahead.
If pipe PSP was measured at pipe top and at depth it is found more positive, what does it imply?
Can you please repeat the question?
In the pipe to soil potential measurement, it is measured at the pipe's top and at its depth, and in the depth area it is found more positive. The potential is found to be more positive. What does that mean?
Yeah, that means, I mean, when you say it's potentially positive, right? Potentially is positive.
Yes, in the depth compared to the top of the surface.
Okay. Positive, what probably your meaning is then less negative, right? I think if you are able to properly connect the polarity of the your voltmeter correctly with the reference electrode and the pipeline, I don't think you should ever get a positive, unless otherwise it is too much of stray current, it's going beyond, actually, right? It's still possible to get a positive current. Okay. So what it essentially means, if I understand correctly, the current is leaving the pipeline, actually, right? So current is leaving the pipeline. That means it is possible that there is a stray current over there. And I do not know whether the pipeline is suffering corrosion at all, actually, right? So essentially, the stray current, leaves a pipeline. That must be something nearby structures are receiving the current, right? So it is very likely that that what you're talking about at the deeper in the in the system. That is, it's essentially your pipeline is acting as a drainage point, right? It's something like an anode. So you would better look at it actually and see whether there is a loss in thickness that taking place. Okay, otherwise, I would not really expect, normally the natural potential could be about minus 0.6 or something like that, right? Going to positive value essentially means that there is anodic current leaving the pipe actually, if I understand your question more correctly. So it means the say current corrosion is occurring, which means also you can also measure the pipeline current, see whether it happens. Then what I would suggest is you also make a CIP or a distance, right? You measure CIP over a distance and see that where the reversal is taking place, right? The reversal will takes place at a far away distance. So which means the segment which you are suspecting is acting as an anode. So you also suspect that something else in the vicinity, the current is is being sent from the pipeline. Thank you.
There's a question from Sankal Srivastava. He's asking, for ICCP systems, can we have consumable anodes?
Well, I think, yeah, this is, it's interesting question, actually. See, when we talk about ICCP, one thing is very clear, that the dissolution of the anode, okay, does not add to the current required for cathodic protection, okay. So what do I mean by this? Suppose you have a sacrificial anode, sheer dissolution of the anode produces electron, and these electrons travel to the pipeline and get cathodically protected, right? So the role of a sacrificial anode is to provide the current, to provide the driving force, right? So that is also a consumable anode. That is called sacrificial, or you can use the term very vaguely as a consumable because it consumes. In order to distinguish a sacrificial anode of this type, where it is meant to provide current and also driving force, from that of the one you are referring in the ICCP, you call them as consumable anodes. So what is a consumable anode here? The role of the anode still is to pass the current on the earth, and still you need rectifier. You still make them as anode. Forcefully you are making them as anode. Now, why you call it consumables? Because they are not stable. Why then people use it? Because sometimes it's cheaper. People can use scraps, or you can even use some of them. Okay, scrap, that doesn't cost you much. You keep on replacing them again. But of course, then you need to keep replacing again and again. Okay, this is as opposed to, let's say, like titanium insoluble anodes. It's been for a long, long time. They're called dimensionally stable anodes. And even the graphite anodes are maybe, iron silicon anodes, for example, okay, and or even lead anodes. They are not considered to be like a consumable anodes because even though they also, there's a loss of weight, but then they have a much longer life. So they don't come into the classification of what is called as a consumable anodes. Yeah, consumable anodes in principle, yes, is possible, but it may not be applicable, everywhere, So I hope that I made the point clear.
Yes, sir. Thank you for answering. There's one more question. Can we alter the conditions of the soil, such as pH, resistivity, in cathodic protection of buried structures?
Yeah, see, the cathodic protection per se, well, if you look at in principle, it can change the pH a little bit on the pipe surface, little bit. Why I say little bit? Because when you are going to make the pipe as a cathode, assume that there is a small amount of hydrogen evolution. And so over a time period, the pH may become a little more alkaline. And so, in fact, what happens is you'll also see, okay, it's possible, it can happen, right? And also what also can happen is that the pipeline also will interact with the soil and can start passivating. By naturally, it can also do that. So the current demand may decreasing. So otherwise, I do not expect the soil to change its chemistry per se because of cathodic protection. Okay, pH can possible if, especially when you're going to do a very high negative potentials, right? And like beyond one minus 1.2, so you may have some hydrogen evolution, which of course is not a good thing, right? Thank you.
Thank you for answering, sir. There is one more question on an assignment again by Sridhar. I would suggest to go through the detailed solution because there are two documents, one giving only the answer, and there is one more document giving a detailed solution. I'd request you to go through that steps given in the detailed solution, and if you still have doubts, please write to us so that we can clarify.
Okay, so no other questions now, Kritika?
Yes, sir, no other questions as of now.
Okay. Yeah, just give another minute or so, and if some people still think to frame the questions, we give some time.
Sure, sir.
Okay, so you're not receiving any questions so far?
No, sir, nothing new as of now.
Okay, so okay, guys, thank you very much. All those who have come online to clarify the questions. And if you still have any questions, or if still you feel that you're not got sufficiently answer for your questions, please do communicate to us. We'll try to clarify your doubts. And I do hope that you will have a useful NPTEL course to address both the science aspect of cathodic protection and to a certain extent the application of
So sorry to interrupt. There is one last question.
yeah.
What would be the effect of weather conditions on cathodic protection performance?
Well, I think it's possible, right? I think so when you say weather conditions, you mean the rain, right? I think, right? I mean, otherwise, suppose it's raining now, the soil becomes wet, right? And this especially will happen when the coatings are not very good, right? The coating slowly deteriorates, for example. Okay. So the electrode or the pipeline get polarized. So it's very similar to the current demand for a pipeline in a soil of high resistivity as opposed to the current demand in the soil of low resistivity. See, in fact, if you look at the IS standard, for example, there is also the current demands are given clearly what type of coating, what is the soil resistivity. Okay, they're given some kind of thumb rule, right, which is relates to resistivity and the current demand. And then if it rains now, you'll find that the current demand may be increasing because the resistivity of the soil decreases, right? But of course, when it becomes dry again, the current demand may come down. I hope that that's what you mean by weather conditions, right? Yeah. Thank you.
One more question is that SSD is bipolar or unipolar?
Kirti, can you please repeat that question?
SSD. He's asking about SSD. I think
Can
he's
you
talking about the decoupler in cathodic protection.
can you please elaborate the question?
I request Jagan to elaborate this question. Can you please provide the email to contact? Yes, Sridhar, it is available on the discussion forum. You can write there, or you can also write to Professor V.S. Raja from IIT Bombay. There is one more advice questions like how can a metallurgical engineering background graduate start a career in corrosion engineering?
It's a good question. I mean, see, in my experience, metallurgy plays a very major role in mitigating corrosion, actually, right? If people don't apply the metallurgical background and you look at corrosion, it becomes like electrochemistry, actually. The same is true if you are simply a metallurgist, if you don't understand the electrochemical principles and corrosion principles, you remain as a metallurgist. So, if you want to be a very successful corrosion profession, I think you need to have a clear understanding of the role of metallurgy in corrosion and also the electrochemical corrosion concepts. Not only electrochemical corrosion concepts, even otherwise like stress corrosion cracking, the variety of things, right? So, in my view, what I've seen, I've done consultancy for several industries. I mean, this is a very niche area, right? There are people who do consultancy just by hearsay or just by experience like that. The challenge that comes to corrosion, professional is that you don't see same kind of corrosion problem, every time. The solution also may not be the same. You see, there may be stress corrosion cracking happening everywhere, right? Wherever you talk about. But the solution to the stress corrosion cracking may not be the same because it involves localized issues that involved there, right? So you will see broadly, there are 7, 8 forms of corrosion or maybe 9 forms of corrosion like that, right? But you don't have only 9 solutions to the problem. The solutions are very, very broad. That depends upon the local conditions or the cause that led to the SCC behavior. There can be several causes that could lead to SCC behavior. There can be several causes that would lead to, when I say several different types, I would say, okay? Causes that may lead to pitting corrosion, SCC, and so on and so forth. Okay. So it's possible, right? For example, you may have a sensitization in even 304L industrial. If the guy has not done a proper solutionizing treatment, right, or maybe quenching treatment, okay. So it's not that things are given just like that, So you need to understand the mechanisms in order to find the root cause of the problems. Okay, so yes, I think you're ideally suited for solving the corrosion problems. But then if you remain as a metallurgist, then it's an issue actually. Okay, you should also broaden your understanding. You should be as good as in corrosion as you do in metallurgy to solve the problem. So ideally, both of them will give you greater strength to be a successful corrosion profession. Thanks for the nice question.
Yes, sir. Bringing back to the previous question, a student has asked whether a solid state decoupler is bipolar or unipolar. But I would request, I think the context of the question is still missing.
Yeah, so what I would suggest to you is still, we would like to try to answer your question. You please do send. Yeah, you can say bipolar. I mean, sense in a way, I mean, you see, if it's really an isolator, then it should not be actually right. But then current passes. So sometimes what happens, there is separation is there, the current leaves one side, enters other side. You mean that is bipolar? So I would like to know see, insulator doesn't have any property, isn't it? But what I understand from you is that suppose there is a resistance and you have a decoupler, for example, and if the current has to jump from the pipeline to soil and then enters like this, you mean that? So some kind of clarity is required before I could be able to answer this question. Yeah.
With this, we have answered all the questions in the live.
Okay. Okay, guys. Yeah, thank you very much, and hope that this interaction has been useful to you. Thank you.
Yes, sir.
Okay, sir. So shall we stop the streaming?
Yeah, please. Actually, yeah.
Okay, thank you.
Yeah, thank you very much.